Welcome everyone. I'm Nick Kuhn. I work at VMware Tanzu. I do tech marketing. This is a pretty short timeline to talk about this topic, so I'm going to try to move pretty fast. And if you have more questions afterwards, feel free. We can continue discussion later. Quick disclaimer: I don't think we're going to need this, but just in case we do, we always like to put that in all my slides. But a quick view. We're going to just cover briefly what Tanzu Platform is. I'm probably going to speed through that pretty quickly, and then I'm going to really talk about what we've learned about large language models, particularly like local large language models, running them in production for about 2 years now with our generative AI tile and Tanzu Platform. And then I'm going to, maybe if we still have time, kind of walk through some of these thought processes we have with an actual example model. I'm going to skip that just because of time. But if we really think about what VCF is, if you don't know what Tanzu is essentially like a Google Cloud Run or an Azure App Service on top of VCF. So it's a platform as a service. It makes it really easy to push app code and to deploy things like databases, API gateways, message queues, etc. for developers, and that's all runs great on top of VCF. Now, first and foremost, if we kind of drill into where this experience comes from, we have a marketplace and we have many tiles or many services that you can add into the marketplace. One of these said services is our generative AI service, where we can broker to, host, and bind to different large language models, whether that be external models like ChatGPT or Google or Anthropic, or models running on Tanzu or even VMware Private AI Foundation models. A lot of this talk's going to be focused around the private side, the non-external, the local models running in your data center, what you have to work through to get those going. And some of these, or a lot of this, is really taken from real-world customer examples. I'm going to skip that slide. And just a quick architecture view of what we're going to be talking about, how we learn some of these things. We have an application runtime where we push applications to it within the platform. But then we also have an AI tile that I talked about. We run the Tanzu AI server, which is kind of like an AI router, middleware layer, which kind of do this key exchange, rate limiting things to broker and present to other models. We can run models on Ollama, on vLLM, CPU, or GPU. We can bind to our data services like Postgres, Gemfire, Greenplum. That's kind of what's going on behind the scenes. If you have more questions about this, we can go into it a little bit later. Additionally, if we're using VMware Private AI Foundation, we can just talk to those deep learning VMs that are already deployed and have a similar experience. But let's talk about the first kind of problem that we see. And we talk about our Enterprise IT Council, or really what we're seeing now dubbed as the AI Council in customers. Getting a model approved through that pipeline can take a long time. We're kind of going back to this thing of like some of our customers have to put in requests as new models come out to get models approved. And if they're lucky, they can go target a certain family of models to get approved. As they get updated pretty frequently, and they don't have to get every subversion of that approved by their council. Based on what the company is, what they do. They may be a federal contractor, they might be in the defense sector. That's really going to limit some things, and we'll go from here. So we take a real-world example of navigating some of this AI council. If we look at what could be achieved, so if you look at the first, like Mark Zuckerberg's Facebook Meta, the Llama models, you may think that might be okay, but no, they've been denied because there's license clause about large companies reaching out to Meta about if you're over a certain size, you need to talk to them and work out a deal about using those models and paying them. The Mistral model family from a French company has been approved, but only their Apache 2 models, right? So they also have closed source models and other models that have certain clauses in them. Gemma from Google denied. Well, they are a defense contractor, and there's clauses about the Gemma license about do no harm and things of that nature. So that's kind of a problem. Qwen 3, DeepSeek, basically all of the Chinese open source models denied government reasons, which is unfortunate because they are very powerful. They have some SaaS approved, like limited use of OpenAI and Azure OpenAI, or Azure AI, excuse me, but only really for public data sets or maybe certain line of businesses. But this certain customer has whole lines of businesses that are just, thou shall never public cloud, and that process, thou shall never public AI as well, kind of applies there as well. They have submitted a request to get GPT OSS, which is OpenAI's latest open model. And that was great because it's actually an Apache 2 model. It's actually pretty performant, and it's got proper sizing. So they're trying to get that approved, and we'll see where that goes. But that's sitting in queue of the AI, still currently, from last I've heard, still sitting in the queue of the AI Council to be approved or denied. So that's just one challenge that you may have learned, and that's what we kind of help folks talk about and kind of give guidance on. But it's going to be definitely it depends scenario based on what you do, what country you're located in, and who you do business with. Now, next that you may have to work through, it's always the firewall, right? So most customers have firewalls in place. They have outbound web proxies in place to block traffic, things of that nature. And when you talk about if you do get models approved, how you have to source them, like a lot of popular locations is Hugging Face. So if you haven't heard of Hugging Face, it's kind of like the GitHub for AI models. That is commonly blocked in most places, as well as maybe the Ollama library, which is another place to get models. So you may have to open up a request or approval process to get maybe like a service account to access those, or maybe finally document what you can get access to via the internet. We have some customers like using Artifactory, like they pull external packages like node packages and all these external application packages for like build processes normally as well. Hugging Face has Artifactory has a Hugging Face integration. We've also seen some issues around the size of these models are quite large. You might have 10, 20, 50, 60, even hundreds of gigs of file size in some of these models. And we've seen Artifactory, let's just say, struggle a little bit. They're working on it, but typically that's a new type of workload. When those Artifactory teams get presented with this, that's a challenge. A lot of this ends up being maybe we can get a model proxied through Artifactory, but then we're going to want to put that like on a local S3 or file share just to work through the air gap. And probably S3 is a better suited, just normal traditional file server is probably better suited because of such large file size of some of these models. And then there's also, if you've seen the VMware Private AI Foundation, I think the latest release, they've released a model store based on Harbor, which could really help solve some of this problem as well. So I'm looking forward to seeing how we can integrate with that and use that more too. And then also they have a partnership with NVIDIA, where NVIDIA, you can also download models through the NVIDIA AI Enterprise Suite and get models that way too. So those are kind of some of the things we've seen about getting models approved, getting models sourced and downloaded within your ecosystem, past all your firewalls and proxies and such. Now, if we look about, once we have the model, right, how do we run it, right? And some of these, I've used ChatGPT to make these images to kind of be funny here, but we take a large language model and they might crush your GPUs. And that's what I'm trying to do here with this. But you should really try to make the most out of your infrastructure. There's probably a large chance that you either have no GPUs available to you or very few. And if you do have those GPUs, they're going to be heavily contested space to use. But we see a lot of our customers will start with CPU inference and we'll start building out those POCs, because you need to have a business case to justify, hey, we have an application prototype, it's working, but to take it to scale and process thousands of requests per second, we really should probably buy some H100s and build out a dedicated GPU farm for vSphere and such. So how do we justify that price? Because H100s are like $30,000, $40,000 a piece, and you load a host up with a bunch of them, like we're talking maybe $250,000 just for a single host, right? Not super cheap infrastructure to just get approved off the bat, right? So I guess my lessons learned or stuff on this nature is start with what you have. You may, additionally too, you may have old VDI clusters that aren't in use. that may have some GPUs, we can help you get started there as well. And that may even be sufficient for some of the smaller models. And then also, if you're getting newer hosts with some of the newer like Intel processors, they have an Intel AMX extension set that helps process models faster. And as hosts become newer, you get faster and faster memory, which helps improve inference speed as well. All right, this is my take at the Spider-Man meme with all the different inference engines pointing fingers at each other. But let's talk about inference engines, right? Because how you run these models matter as well. So if you look at vLLM, it's by far the best, most performant inference engine to host these models on once you get them in your four walls. But it can be very complex. It has a lot of like sub-dependencies, like Hugging Face transformer dependencies, a lot of Python packages. So it can be a very complicated Venn diagram to get everything plugged up right. And it's also very picky on hardware, as in they've already started deprecated non-Antmere based GPUs. So if anything below like the A series of GPUs, like if you have Tesla T4s, which are still very prevalent and still very affordable, those are starting to be deprecated out of their new engine. So they're pretty aggressive on deprecated gear that may still have many years of life in it, especially with GPU constraints. So that can be potentially a problem. But if you do have some of the newer gear, it's pretty nice to have that. And then the Private AI Foundation solution, the NVIDIA containers that ship with that, I believe they wrap vLLM as well. So that's kind of like the performance king, but that has a lot of challenges sometimes as well. If we talk about Llama CP, Llama CP is a pretty popular project. It's kind of similar to vLLM, but it's a lot more flexible and not as strict about what hardware you can handle, and it does actually CPU inference pretty well. You can do a lot of like tweaks as well to it. But what you may have heard of Ollama, which is essentially some folks from Docker left and made this company called Ollama, and they made a very Docker-like wrapper on top of Llama CP, where you can do like Ollama run model XYZ, and it like kind of pulls down an image, and it feels kind of like Docker. So they kind of added some additional wrappers and kind of made that more usable for the masses. They actually released like a desktop application as well, if you're running it on your PC at home, that type of thing. So there's kind of two trade-offs, and we ship both of those just because it's really easy to get started with Ollama, and it's easy to get started with CPU inferencing. We actually also have a lot of certain type of workloads, certain type of models, like we talk about an embedding model. That actually works pretty well on CPUs, and a lot of people are happy with that, and they don't want to waste their GPU resources on embedding models. So we can spin embedding models up and down and just run on CPUs alone. And there's many other inference engines out there. It's always changing. There's a couple of different forks of Llama CP out there. It's a space that never ends. Now, we talk about if you've ever worked with a large language model and you're feeding it data, and then it just feels like it forgot everything you just told it, right? Well, what we're really talking about is context size and quantization. So the context size is extremely important to make sure you get that set properly. If you set it too low, you're going to have people try to use those models, and they're going to be like, hey, I just sent like 100 documents to this model, and it just like kind of crashed in the meantime, or it just keeps looping and like hallucinating over and over again. Well, check your context size. Oh, well, it's set to the default. It's only 8K. Well, that model can run up to 128,000 tokens, and you're only using 8,000. So you should bump that setting up to make sure you can get the most context possible, because that's like the short-term memory of the model. As soon as that context size starts filling up, it's going to start dropping things out of there, and so it's going to start losing that short-term context, right? So it's critical that you have that larger window set, especially if you want to do tools or function calling, that they require a larger context window. If you want to use like the C-line VS Code plugin to do kind of like vibe coding and things, you'll see that they all want large context windows to be successful. You may have heard of this term called quantization. That's really like compressing a model down, like maybe like a JPEG lossless image compression, right? But every time you layer that down, there is some trade-offs. And I guess we got a few minutes here. The best way to kind of like show that is to look at like Hugging Face directly and see how these are processed. So let's go here. Okay, so one of these models, which we use, it's called DevStrol, which is really a fine tune of Mistral Small, geared for like vibe coding. And if you saw my presentation earlier at the VMware booth, I was actually using that to vibe code an application we pushed to the Tanzu platform. But how do we work about the quantization levels, and how do we figure out what we can run, right? How do we fit it on those GPUs? So you see here, like 8-bit, 6-bit, 5-bit, 16-bit. So 16 bits, the full size of the model without compression. And that's going to be, let me zoom in a little bit more. That's sitting at 47.2 gigs. And if you wanted that run that model completely in GPU, you're going to need at least 48 gigs of VRAM. That's already a pretty large card or multiple smaller cards. That does not include any overhead for the context window size you want to set, or the KV cache, which will increase that as well. So you want to leave room for that. So that's realistically probably a much larger card. Maybe like that could fill up an H100 with a larger context size and KV cache set. So a lot of people go lower for quantization because they don't have a larger gear. But every time you go lower, you have that quality degradation in the model. So I like to shoot for like the 6-bit or the 8-bit seem to be the most trade-off in. I'm going to go from needing 47.2 to like 25, maybe even a 5-bit. And some of these models that get published, the folks who publish them, Unsloth did this one. They're pretty popular in this space. They'll even do maybe some documentation of like, here's how we feel like these different quantization levels perform. But it's definitely going to be something you want to try out and test on your own use case, because every model kind of performs differently, and depending on the use case, it may react differently as well. So that's just a quick example of how that looks like. Obviously, it's going to be based on how you can get that going. And specifically for this model, what I ran earlier, I actually used a 5-bit Q5KXL, which is 16.8 gigs. And with my context window and my KV context window size at 128K tokens and my KV cache set to Q4 quant, I was using about 25 gigs of VRAM. So you can see that additional overhead split across those, and I balanced it across 2 GPUs to run that. So that is something to keep in mind. It can be quite challenging. There are some like memory calculators to help kind of figure some of this out, but they're kind of, your mileage may vary based on that type of thing. So wake up here, and we'll go from there. But we got like less than 2 minutes left. I'll go back to my slides here. If you're interested in kind of learning more about Tanzu Platform and what we do with AI, we have a starter kit here. You can check that out. You can come see me at the Tanzu booth pretty much all week. We can talk about that all day, every day. And we'll have some materials here to get you started, and you can even kind of bootstrap this whole platform if you want, just with a kind of a simple PowerShell script and get going. And then last but not least, if you like this talk, I host a weekly podcast that we talk about Cloud Foundry stuff, which is what Tanzu Platform is based on, and AI. And we're kind of becoming more and more of an AI-related podcast as well. We actually have some friends of the pod in the front row who've joined the show too before. Check that out. Like, subscribe. That'd be great. We have a lot of conversations and topics around these type of areas and running AI workloads in production. But that being said, any questions? We got less than a minute left. Go for it. If not, thank you for coming.